Hi, Algebra 1 students. Today's notes are on solving one-variable equations. So before we get into actually solving one-variable equations, and that process actually should be pretty familiar for you. You've done this in 8th grade. But I just want to review what are our properties of equality, because you're going to be using all these properties when you go to try to solve equations. Okay? So the first property we talked about here in this chart, we have the associative property, right, which says that you can group terms differently and the order in which you group them doesn't matter. The next property is commutative, which says you can switch the order of terms when you're adding or multiplying. And then lastly, we have the distributive property, which says we can multiply in a term on the outside of parentheses, right? So A times B plus C becomes AB plus AC. Now, I'm going to leave the examples blank, and I'd like you to come up with an example of an equation that uses each of those properties. So in these example boxes for these 3 rows, you should fill in with an example of your own, okay? But for these notes, we're actually going to introduce a couple of new properties which we're going to use when we solve equations. I'm going to kind of group 2 properties together. So the first 2 new properties we're going to look at is the addition and subtraction properties of equality. And I'm grouping these together because we can kind of think about subtraction as the addition of a negative number. So it's kind of like the same thing as addition. So the addition property of equality says that if we have an equation that says A equals B, so if A equals B, then the addition property says we can add the same thing to both sides and it preserves the equality. The equation is still true. So for example, it says then A plus C equals B plus C. Okay, so if we look at an example of this, we can think, let's suppose x plus 1 equals 5. Okay, so that's my initial equation. So that's like my A is x plus 1 and my B is 5. Now, if I think about what are the solutions to this equation, well, I could imagine plugging in 4 for x and I get 4 plus 1 equals 5, and that would make this equation true. So a solution here would be 4. Now let's think about what happens if I add the same number to both sides. So let's try adding 2. Then my new equation would be x plus 3 equals 7. Well, if you think about this new equation, x plus 3 equals 7, and you plug in 4, right? Remember the solution to the original equation was 4. So if we plug in 4 for x here, we get 4 plus 3 equals 7, and that is still true, right? So we show that just by adding the same thing to both sides or subtracting, we get a new equation, but it still has the same solution set. So the next property we're going to look at the next properties are going to be the last 2 operations. So that's multiplication and division, and we're going to think about those together as well. So we have the multiplication property of equality and division property. Okay, and they say, well, if A equals B, we're going to start the same way. Then I could multiply both sides of an equation, or I could divide both sides of an equation by the same number or expression, and I would still get an equation that is true. So then we have, suppose I multiply both sides by something called C, I would get AC equals BC. And then if you're thinking about the division property, it would be A divided by C equals B divided by C. Now the only difference here is that whatever you're multiplying or dividing by, it cannot be 0. So here, this property only works for non-zero values. And we'll kind of explore the why we can't use 0 a little bit later in the course. Okay, so just take me at my word for now. And then if we think about an example here, we're going to start with the same equation we did in the previous from addition and subtraction. So we can start with x plus 1 equals 5. And we know that the solution here is 4, just like it was before. So now what happens if I say multiply both sides by a number? And I'm going to choose 2. So what happens when I multiply both sides of this equation by 2? I get 2x plus 2 is equal to 10. And if you think about what happens if I plug in 4 to this equation, I get 2 times 4 plus 2 equals 10. Is that true? 2 times 4 is 8 plus 2 is 10. So that works out, right? So the big idea behind these properties of equality is that these properties preserve equality. And what I mean by that is that by applying one of these properties, you're going to get a different equation, but that new equation will have the same solution set. So the idea of preserving equality means we're going to get the same solution set. And this comes in handy when we're trying to get to a solution. We're trying to find a value that works in an equation, because it means I can apply all these properties. I might get a new equation, but ultimately the solution I get should still be the solution of the original equation, right? So we're going to look at a couple of examples now. In example 1, I have 4y minus 3 is equal to 5y minus 8, and my goal is to get y by itself, because if I have y equals something, then I've arrived at my solution, right? So the idea is we can use these properties to try to get y by itself. Well, whenever you have y's on both sides and variables on both sides, you kind of want to sort them over to one side or the other. So you want numbers on one side, variables on the other side. So in order to do this, I'm going to start by adding 8 to both sides. It doesn't matter. Like, I could have also started by adding 3 to both sides. Having a hard time drawing a plus sign. So if I add 3, I said I was going to add 8. If I add 8 to both sides, I've just used the addition property of equality, right? So this is the addition property. And I'm writing my justification here. This is kind of like making a proof as to why a certain solution is the solution to an equation. So when you go to do your you-try examples, I want you to write down which property you used. So if we add 8 here, I'm going to get 4y plus 5, because negative 3 plus 8 is 5, is equal to 5y. So now, I'd like to have my variables over on one side, and right now I have a 4y and a 5y on either side. So I'm going to scoot the 4y over to the other side by subtracting 4y from both sides. And that would be the subtraction property. And my new equation, which should have the same solutions, right, is going to be 5 equals 5y minus 4y is 1y, which is just y. And now I've arrived at my solution where I have y equals a number, right? So this tells me that my solution set is 5. And I can write it in set notation with the squiggly brackets as 5. Okay, let's look at example 2 now. So in example 2, it's a little bit more complex. Whenever I see like a number outside of parentheses, I'm automatically thinking, oh, I could use distributive property here to simplify first, right? So I see I could use distributive property on both sides. So I'm going to distribute the 2 on the left, and I'm going to distribute a negative 4 on the right. So be careful when you distribute a negative. So on the left-hand side, I'm going to get 2x minus 5 is, and then, 2x minus 10 is equal to, that 5 is just going to come down here, And then I have negative 4 times 3x is going to become negative 12x. And negative 4 times 5 is going to become negative 20. Okay? So when I'm justifying that step, I'm going to say this was the distributive property. Okay, so now the next thing I want to do is I can still simplify the right-hand side of my equation a little more because I see I have that 5 and the negative 20, right? So I want to combine those like terms. So that kind of means I'm using the associative and the commutative property because I'm going to kind of switch around the order here. So I can kind of switch the 5 with the negative 12x and then combine 5 and negative 20 to be negative 15. So that's going to give me a new equation, which is the left-hand side stays the same. 2x minus 10 is equal to negative 12x, and then 5 minus 20 is negative 15. Okay, so I use the commutative property here to switch the order, but I also use the associative property when I did 5 minus 15 because I added those things first. Okay. So now this equation, this line of the equation actually kind of looks like example 1 where I have a variable and a number on each side, right? So the goal is to get all the variables on one side, all the numbers on the other side. So I'm going to do that by first adding 10 over, and that will give me 2x equals negative 12x minus 5. The property I just used was the addition property. Then the next thing I'm going to do is I want the variables on the same side, so I'm going to add 12x over to the other side. And that will get, so that was the addition property again. And that gives me a new line of my equation, which is 14x is equal to negative 5. Okay, I'm running out of space a little bit, but there's only one more step. And the idea is in order to get that x by itself, I would have to divide by 14 to cancel out the 14 that's out front. So that's the division property. And then I've now arrived at my final answer. I'm going to write this in a different color so we can definitely see it. So my final answer is the 14s cancel out on the left, so I'm left with x is equal to negative 5 over 14. So I just have a fraction. 14 does not go into negative 5. And if I was writing that in set notation, I could write it as squiggly brackets, just a negative 5 over 14. So we have two more examples to take a look at, and both of these involve fractions, your favorite, I'm sure. So I just want to kind of review how do we get rid of denominators. So in example 3, we have x minus 7 all over 3 is equal to 4. So the first thing I want to do here is get rid of that 3 in the denominator. So it's being divided by 3, so to undo division, I'd like to multiply here. Because if I multiply by 3, I get 3 divided by 3, which is just 1. Right? So that's going to cancel out the 3 on the top with the 3 on the bottom. And on the on the left-hand side, I'm left with just x minus 7. On the right-hand side, I have 12, because 4 times 3 is 12. And the property I just used was the multiplication property. Okay, so now I have x minus 7 is equal to 12. To get rid of that minus 7, because right, the goal is to get x by itself, would be to add 7 to both sides. And my new equation would be x equals 19. And that would also be my solution, right? Because I have x by itself is equal to a number. So that means the solution set here is just 19. And the last line in my kind of like justification for what property I used, I added, so that would be the addition property. Okay, so now let's take a look at example 4, and this is a problem that kind of looks crazy as it is. We have 0.03 plus x over 100 is equal to 6x over 100 minus 0.02. So I'm going to show you guys a little trick, which is if you have fractions on both sides with the same denominator, the first thing you could do would be to multiply both sides of the equation by that denominator. So in this case, our denominator that I'm looking at is that 100. And we're going to see something really nice happen if we multiply both sides of the equation by 100 at the very beginning. Okay, so remember this is distributive property, so I have to multiply 100 times 0.03. And if you know the trick, it's moving the decimal point. You'd move the decimal point over 2 spots because there's 2 zeros in 100. Or you can just do, if you just do 100 times 0.03 in the calculator, you'll see that you get 3. So when I distribute this in, I get 3 here. And then 100 times x over 100, well, the 100 on top cancels with the 100 on the bottom, so I'm left with just an x. And then on the other side of the equation, something similar happens. When I distribute 100 into 6x over 100, the 100 on top cancels with the 100 on bottom. I'm left with a 6x. When I multiply 100 times negative 0.02, I get negative 2. Okay? So within one step, by multiplying by 100, so we use the multiplication property, in that one step, I turned what looked like a really complicated equation into something that looks very familiar, and I now know how to solve. So from here, I'd know I just need to get my x's on one side, my numbers on the other side. I'm going to start by subtracting x from both sides, so that's the subtraction property. And then my new equation would be 3 is equal to 5x minus 2. My next step would be to add 2 to both sides to get the number terms on the same side. And I have 5 is equal to 5x. So that was the addition property. And now, to get x by itself, I'd have to divide by 5 here. So on the right-hand side, that cancels out the 5 on top with the 5 on the bottom. So I just am left with my x, which was my goal all along. And then I say that is equal to, on the right-hand side, 5 divided by 5 is 1. So I get x is equal to 1, and I can write that in set notation, just like that. All right, so those are our examples, and there are 4 problems for you to try on your own, and I'd like you to write out each property that you use along the way. So we're looking to see that you wrote the property next to the step as you go to solve. And we'll definitely be discussing this in class and doing more practice problems in class.